Hey students, are you ready to learn?
In three, two, one.
Welcome to my channel.
Good morning, class. Our topic for today is all about group theory. Let's talk first about group. A set G together with a binary operation is called group. Binary operation star. A binary operation star called group. Star can be addition, subtraction, multiplication, and division. We say that a set is a group when we satisfy the four properties. What are the four properties? The first property is that G is closed with respect to star. So when we say close, from the set, let's have an example. The integer under addition. We say that this is close when we will get two elements from integer. We have the -2 and 3. We get the two element, -2 plus the operation plus 3 is equal to 1. Thus, 1 is an element of integer? Yes. Therefore, z at the integer under addition is closed. Second property is that star is associative. Associative. When we say associative, the symbol is like this. A star B star C is equal to A star B star C. So, we will gonna use again our first example, the integer under addition. So, let our A be the -2, our B is 3, and our C is, let's say 1. So, let's just substitute. So, -2, the operation is addition, plus 3 plus 1 is equal to -2 plus 3 plus 1. Is it they are associative? Let's see. So, -2 plus 3 plus 1 is 4 equals, question mark, -2 plus 3 is 1 plus 1. -2 plus 4 is 2. 1 plus 1 is 2. Therefore, the integer under addition is associative. Next property, it should have an identity. Has an identity. So, what is the identity of an integer? Our formula for this is that A star E is equal to A. So, what is the identity of integer under addition? What is the identity of 2? When we add, what are gonna do? When we add, we should get 2. Is it? Yes, 0. So, our E there is 0. Let's just substitute. Our A is 2 plus our E is equal to, our A is 2. Our E, 2 minus 2, E is equal 0. Therefore, our identity here is 0. The fourth properties is, it has an inverse. For inverse, we have, again, the integer under addition. Get an element from that. We have 2 is equal to 0. What number should we add so that we get 0? It is, let's say, negative 2. 2 plus negative 2 is 0. In short, we can get the inverse by doing like this. 2 plus a prime is equal to 0, where a prime is equal to negative 2. Therefore, our answer is negative 2. So, that are the 4 properties so that we can say that a set is a group. Let's have another example. Since we have the integer under addition, let's have positive integer under addition. Is it group or not? First, it should be close. Yes, it is close. Whenever get two elements and add, we will get another elements from the positive integer. Let's have an example. 1 plus 2 is 3. 3 is an element of positive integer. So, first property is correct. Next, second property. Second property is that it should be associative. We will get 3 elements. So, from the positive integer, we will have 2 plus 3 plus 4 is equal to 2 plus 3 plus 4, question mark. 3 plus 4 is 7. 2 plus 3 is 5 plus 4. 2 plus 7 is 9. 5 plus 4 is 9. Second property is satisfied. Third property. Our third has an identity. What is an identity of a positive integer? Again, our identity here is 2. Therefore, the third property is satisfied. Last, our fourth property. It should have an inverse. So, we already answered it a while ago. So, our inverse is 0. No, our inverse is negative 2. Sorry for that. Our inverse is negative 2. Therefore, we satisfy again the fourth properties. Therefore, our conclusion there is that the positive integer under addition is a group. Let's have the abelian groups. If a set is already a group, then, and it is commutative, it is called abelian. So, if you satisfy the fourth, or the set is already a group, and add the another properties for abelian, which is commutative, it is called abelian. So, let's have an example. We have Q plus under multiplication. So, we have the positive rational number, set of positive rational numbers under multiplications. So, first property, we must prove that it is abelian. Let's satisfy the 5 properties. It should be group and it should be commutative. So, first, is it closure? So, we should get 2 elements from positive rational numbers. We have 1/2 and 2. 2 can be is or equal to 2 over 1. Therefore, it is a rational numbers. So, 1/2 times 2 over 1 is equal to 1. 1 is a rational, positive rational number? Yes, 1 is a positive and it can be written as 1 over 1 or 1. The first property is satisfied. Closure is satisfied. Next, we have closure. Next is associative. So we have 1/2, 2/1, and 1/1. So let's see if it is associative. We have A star, B star, C is equal to A star, B star, C. So we have 1/2 times 2 times 1 is equal to 1/2 times 2/1 times 1. Is it associative? So we have 1/2 times 2/1 times 1 is 2. 1/2 times 2/1 is 1. 1/2 times 2 is 1. 1 times 1 is 1. Therefore, it is associative. So, we satisfy again the second properties. Let's have the third properties. The third properties, it should have an identity. Have an identity. So, what is the identity of a positive rational numbers? So, what should we multiply from 1/2 to get 1/2? Is it 0? 1/2 times 0 is 0. Is it 1? 1/2 times 1 is 1/2. Therefore, the identity is 1. So, again, it is satisfied. So, let's have the fourth properties. The fourth properties, it should have an inverse. So, what is the inverse of 1/2 under multiplication? The inverse of 1/2 to get 0 is that 0. Yes, 1/2 times 0 is 0. So, our inverse is 0. Again, our fourth property is satisfied. Last, therefore, the positive rational number under multiplication is a group. Now, let's prove it is abelian. Let's add the fifth property, which is commutative. A star B is equal to B star A. So we have 1/2 times 2/1 is equal to 2/1 times 1/2. 1/2 times 2/1 is 1. 2/1 times 1/2 is 1. Therefore, it is commutative. Since we satisfied all the properties, therefore it is an abelian group. So, positive rational numbers under multiplication is an abelian group. That's it.